think we'll get started. Thanks all of you for being here. I hope you're having a great Claris DevCon, and it's been an exciting couple of days for me. Hopefully it has been for you too. This session is titled Fast Solutions Developed WAN First, and I think you get the idea of the title. It's going to be a session focused on performance, things that you could apply to legacy solutions too, but certainly a lot easier if you start out of the gate with WAN in mind as you're developing. So we're going to look at a bunch of live demos. So we won't spend too much time in slides other than to just sort of introduce some of the concepts. And there's a link up here that's about to disappear, but I tweeted out the link to, and we'll have the demo files available later too. So, all right, so my name's Chris Irvine. And I come from the Northwest, Portland, Oregon area. Let's see, I'm blessed to be married and have 3 kids. We're going through the grade school and middle school season of life, so that's been real interesting. Professionally, I worked with Parent Smith and a bunch of other smart guys, and we ended up putting out a white paper a few years back, Idiomatic FileMaker, which is still sort of the basis of a lot of the work I do. So feel free to look that up if you like to read white paper type stuff. And I started 3Prong after being in-house for a long time, and we consult now, so you can hire us for help with performance or security issues or just about any type of development. We also do a fair amount of Python and PHP work too. So happy to be here presenting. I was glad that they asked me to talk on this topic because it's something that's interesting to me. So let's just look back a little bit of what we've been through. If we look back around 2000 or late 90s, some of you might recognize some of this gear. We had modest 10 megabit networks. Some of the components were kind of expensive. We had to have these Uuid transceivers to kind of make stuff work. Wired connections were pretty expensive. You might have a T1 with 1.5 megabits. That seemed pretty great. You'd go to work to get on the internet kind of thing. And cellular data, as that started coming out, Edge advertised speeds of 200 kilobits. I don't know if anybody ever got that. I don't think I ever did. And then when 3G came out, advertising 5, I still don't know if I ever saw performance that good. If we flash forward to today, we have most of my clients, it seems like everybody's on gigabit LANs. A few of them are even moving to 10 gigabit. Broadband has obviously become a commodity that's available just about anywhere. And cellular data has really shot up. It's actually growing faster performance-wise than most of the other network technologies. So even though our networks are getting better, why do we still care about network performance? So even though the LANs are getting ridiculously fast, our users are getting farther away from the servers. They expect to connect from anywhere. So actually, there's new challenges that we have now that we didn't have before. See how close I have to get. So what are some of the things that we're up against? We're going to talk quite a bit about latency. So this is just the term to describe the amount of time it takes for your client to send a message to the server and for that to make the round trip back to you. And when there's inconsistencies in that latency, we call that jitter, irregularities in the latency. Hopefully you don't have a lot of jitter, but latency is always going to be there. Bandwidth gets the most attention in marketing. Everybody wants to talk about how much bandwidth they offer. And that might be an issue for your solution, but maybe not as much as latency is. And then there's also these sort of unique new problems with people who are on the go. So they might be connected to your solution and they're hopping between base stations, or if they're on cellular, they're hopping between towers. So that might introduce challenges for you. And then network outages, if people are on the go and they go into a tunnel or an area with bad service, how are you going to deal with that? We're not going to touch so much on the whole offline-online situation today. That could be a whole nother series of sessions, I think, to how to best address that. So I decided to just sort of generalize the bandwidth discussion and talk about some of your clients. You could just say that they're on a skinny tube, and everybody on the right side of the line is on a fat pipe. Most of the FileMaker solutions I run into, everybody's going to be pretty happy anytime they're on the right side. I know we get excited about upgrading when we went to 100 base T, and then we went to gig, and now 10 gig. But unless you're doing like a lot of media files or something, it's probably not going to have a real noticeable impact for a lot of solutions. The other part of this that's interesting, I think, is cellular. Cellular LTE performance can be phenomenal, but it's not everywhere. So at least in the town in Portland where I'm at, if I'm in the suburbs doing remote work in a coffee shop, I'd rather tether to my phone than use the coffee shop Wi-Fi. Cellular LTE in the suburb is awesome. But if I go into the urban core, where there's a lot more people, there's buildings, maybe there's RF issues, all of a sudden I get frustrated with the kind of performance I get out of that same product. So it probably depends on your area and if the users are moving between those types of areas if they're using cellular. So the next issue is latency. We'll spend some time on this too. So if you are in the building where your server is, this is where a lot of FileMaker solutions started. Mom and pop business, the business owner is starting to make his own solution to help run the business. The server's right there under the desk, right? We still see a lot of sites like this. So your latency when you're right there next to the server is probably 1 or 2 milliseconds or better. But let's say the business is expanding and you run out of space for people, so you find out that this building across next door is open for lease, so you put a few people over there, and you're trying to figure out how to get them on your server. Maybe you just order another broadband connection and they connect through that common carrier, or maybe you are more careful and use a VPN or something like that. So that sort of intra-city latency is probably going to jump up to 10 or 20 milliseconds, something like that. But what if you don't use the same provider for the broadband at both sites? Then there's a pretty good chance your traffic might even leave town. So we see this a lot in Portland. If you have a server on one provider and a client on another provider, lots of times our traffic will actually go to Seattle or the Bay Area for an exchange between carriers. So then you're going to see latencies that jump up maybe 20, 40. And then I run into quite a few people that are running companies with satellite offices in a different state across the country or even in another continent. And obviously these speeds really start to jump up. And some of these things will maybe get a little bit better over time with better networks and faster routers, but we're really up against the speed of light. If you're going to make a trip around the globe, you can't do better than 133 milliseconds as long as the speed of light remains a constant, or not. We can talk about that later. But and it's interesting, there's some new projects with like satellites, satellite internet covering the globe, but actually that it kind of increases the path, right? Because it's even farther than on the crow flies to the ground. So it'll be interesting to see how that actually pans out. So what can you do about it if your bandwidth is limited? So the main goal here is to just move less data. You might attack that by making narrow records, normalizing your data, something that we all think about probably all the time. And then you might even split up entities, what we'd call partitioning. So maybe some of your customer data is in one table and some's in another, so you can just make records even smaller. Persistent caching, where you download records and then you don't have to get them from the server again. We get this for free because FileMaker's doing this all the time already. And you might do work to limit the number of records you display. If you've got a giant record, you might ask the server to run a script and just give you some important pieces of data off that. That might be a way of avoiding a download. And then containers, it all just depends on what you put in those, but as you access a container, you might be downloading or uploading large files. So thumbnails, things like that, storing metadata outside of the container might be helpful. All right, so we're going to jump out of slides right now and get into the demo. So this is where we hope everything works as planned. So I've got the solution here. It's the same one that you guys could download if you did that earlier. And I've just kind of made a playlist of all the stuff I'm planning on going through to demo here today. And I was going to do a tethering thing with the phone, but it just added too many variables. I decided that we're not going to take that gamble this time. But we are going to look at what happens when you're uploading images from the camera. So one of the things that I ran into on a project recently was like an estimating project where people are going in the field and taking pictures of a job site. And so if you're not already doing this, you can set the default resolution and camera settings when you're capturing into a container. And if you actually go out and start looking at the raw numbers here of what this costs to actually upload, the small picture is only about 20 kilobytes. It's going to upload really quick, even on a poor quality connection. When you go up to medium and large, you can see those numbers climb up. And then when you set to the full setting, I would expect this number to vary based on their device, because then you're actually using the full megapixels of the camera. So I would expect this number, the 2.5 megabytes that my older phone was. If you've got a brand new phone, it's probably going to be up significantly from that. I also, we had a situation where there would periodically be times where they were impatient and they didn't want to get into the solution, or maybe they were having network problems. So they just go into the native camera app and start shooting pictures. And then you don't have any control over the default size. So if they're going to bring it in from the photo roll later, then you can't really, you're stuck with whatever size they captured the photo at. Same thing with videos. So find me afterwards if that happens to you. I actually found a couple apps, like third-party apps that I recommended for like lower resolution video capture to make their life easier when it was time to upload. But I was a little surprised by the results on capturing with HDR and live. I expected a much larger file, but Apple actually has adopted a new compression technology which actually makes that look smaller, almost half the size, or better than half the size of the traditional JPEG compression. So I think it's actually good news that FileMaker is still using the older compression technique, because it has a lot better compatibility with Windows and other devices applications that might not be ready to render those the new compression method. And as I was loading this layout right here, that's just a list of these document records. There's some data at the bottom that I collected by using Wireshark. So I'm actually going to see if I can find that. So you might have seen this. People have demoed this a few times. We're going to have this kind of running in the background as we go. But we can use this to monitor the traffic that's going back and forth between my machine and the server that's right here. So, so as we were grabbing these document records, we can see that we actually only retrieved 36 kilobytes of data over 22 round trips. And that's because the container data is not stored as part of the record. So whenever a field from a record is part of a layout, then you're going to retrieve all the stored data for every record as the records load. Containers come later, sort of on demand. And so we're not paying the penalty to actually download the photos when we load this layout. If we expand the layout a little bit, here I've got, you can jump in here and look, this is actually a calculated button label that's pulling out the file name of the container. So I was kind of curious what would happen here. So the size for these first 5 records to come through did climb a little bit, but it's still only 45 kilobits or kilobytes. I'm still not hitting the full container, so that's kind of cool. And then if we start actually showing the image, we're benefiting here from the server thumbnailing those images. So the server is building an optimal version of this JPEG image for the size that I'm displaying, and I'm downloading a much smaller image. So I'm not paying the full penalty to download the original size files. So that can be a benefit. So this would be something where maybe just displaying an image in a smaller form could be a performance advantage for you, and then give somebody the option to reveal the full version if they need it later. If we keep exploring this a little bit more, I was curious what would happen if I started probing more of the metadata. So this extra column over here is actually the get container attributes all function. So even though I'm not showing the container, because I have a calculation on the layout that depends on the entire container, now all of the container data is actually being downloaded to my client, and the download size jumps up to 31 megabytes. Whether you're showing the container, the size of it, or if you're using some sort of calculation that's going to trigger the container to come down, those would be things to watch for with containers. All right. Oh, and I forgot to mention, the other thing, if you start running statistics on your network traffic, there's 31 megs and the round trips, that's important. This large number of packets might be something that freaks you out, but I wouldn't worry about it too much, because the way the round trips work, if you send a packet across the country and you ask for some data back, think of it like the engine coming back with a whole bunch of boxcars attached. Those are all counted as packets, but they're all coming on a single trip, and so you could get a large amount of data that's broken up into all these cars, but the timing is still more about the engine that goes back and forth. So it might not be such a problem to have a high packet count. All right, and then the next thing I'm going to do here is a little bit of trickery. This might void your warranty. Don't try this on production files, all those sort of caveats. But if you're using FileMaker on any of the clients, Go or desktop, we have these persistent caches now. And so this, on macOS, it lives inside of your home directory under library caches. And these files are being created in here. Oh, I let the secret out already. And these files will automatically be generated. This is what I get for practicing. I showed what I was going to do already. But if we want to start fresh, we can throw away these caches. We'll quit FileMaker, and then we'll reconnect to our solution. And we can see those files start appearing in that directory. This solution has 3 files, so we see one file appear in the cache directory as the first file opens, and then as we start to trigger more data to load, we can see additional caches appearing. It can make it tricky for benchmarking if you're trying to compare 2 different approaches to something, if the cache is sort of interfering and giving you some extra juice on the second try or something like that. So what I ended up doing here is I'm going to shut off FileMaker so it doesn't get angry at me or anything. And I'm going to use the terminal. There would be quite a few ways you could do this. So I've got these 2 cache files right here, and we can see how big they are in this column. And I'm going to just empty those files out by writing an empty file over the top. And we'll wipe out the other one too. There's probably more than one way to do this, but this seemed to work for me. So now we've got empty files there, and then I'm just going to go out to the Finder, get info, and I'm going to lock this file so that FileMaker can't modify it anymore. All right, so what happens now when I fire up the solution is that I get a fresh start. And thank you for some pointers from my favorite engineer from Texas. But basically, caches are still on, but now we're back to sort of the older way where they're per session. So every time you quit FileMaker and come back in, you're going to have a fresh slate. And if you're trying to do A/B performance comparisons, it would be easy to now just shut off FileMaker, start it up, and try the other method and get apples to apples comparison. So we did that. All right, so what can we do to combat latency? And when I visit client sites and we're struggling with performance issues, I would say probably 40% of the time it's a bandwidth issue and 60% of the time it's a latency issue. This is actually usually where we spend more time. So if we could just magically disappear in one place and go to another place, we could solve this problem. So we should all invest in teleportation technology. In the meantime, this problem is often solved with like a terminal server approach. And in this category, I'm just talking about taking the client machine and putting it geographically closer to the server machine, cut down on that latency, and then have a sort of a remote control connection into that client. And I've been using AWS workspaces to do things like this, where I don't have to necessarily invest in a permanent terminal machine. And maybe it's not fair to put WebDirect in this category, but the performance behavior is actually similar in that the WebDirect client is geographically close, usually, to the database server, and so you get a similar benefit where you've shortened the round trips between the client and the server, and then you're sort of getting the streaming view of what's presented on the layout. That guy that opened the office across the alley, maybe he could improve his network by digging a trench, right, and actually solve the latency problem by having a direct connection to the office next door. And then if you're dealing with multiple geographies, bigger organizations are often solving this problem by just having servers in each region, which can solve a lot of your performance problems, but then it creates a new sort of syncing data challenge. So there's a trade-off there. Maybe the performance is more important, or maybe the single source of truth is more important. You'd have to decide on that. So a few of the things that we could do to help improve this, the MVP sort of approach to project management, where you scale back and start with less. Sometimes that could actually be a solution to performance too. I think we're all guilty of occasionally adding really cool calculations or charts or something to a layout that we think is going to be great for the customer, and that might have a performance penalty. Maybe it's something they never are going to use or didn't really want. So thinking about how much to put in and what it's going to cost is, I think, really helpful. The other thing is I really like doing development and QA all on the WAN. So if I expect most of my customers are going to be on the WAN, if I know up front how things are going to behave for them, it just saves me time down the road. And then also just sort of studying what your network is going to be like in production, knowing how much that round trip time is, and then just being mindful of things that you're doing that are going to cause more trips or less trips, and how you can approach that. So we're going to actually, so right here I have a LAN, and the performance is really good, but we're going to actually simulate a WAN so that we can do some of these types of testing right here without even having to leave the building. And then there's other approaches that you could use to maybe accomplish a similar result. So we're going to jump back out to the demo. And I know there was a few more slides, but actually I think we're going to just sort of deliver most of the topics just right in the demo file. From this point on, I don't think we'll do too much more on the slides. All right, so I'm just going to introduce this demo file, this demo solution a little bit. I created a company, Phantom Soda, with just a bunch of random data that I made up. And if you haven't seen any of the solutions I've done before, I'm a big fan of layered software architecture. And so in this solution, there's actually a UI layer file that's called umqua. And then we have a layer underneath that called Wingman, and that's a business layer or scripting file. And in here is some relationship graphs and lots of scripts. And then we also have a bunch of empty layouts. So these are just anchor layouts without any fields on them. So they're very low cost. And then we have our data file. This file has all of our records in it. We'll just look at this a little bit. So this company has inventory records to describe how much stock there is of a given product at a specific plant. We have inventory history that would be like nightly snapshots of that inventory so they could look back over time to see what their inventory levels had been historically. We have 50 plants, so the way I set this up was about 1 plant per state, and then they have 9 products currently, and then their plants are organized into 4 different regions. And then we have a one-to-one or a partition of the region table that's for storing statistics. So those are going to, for every region, there will be a region stats record. And this relationship graph is as simple as possible. It's really just only the table occurrences that are required for the calculations. All right, so we're going to jump over here, and let's take a look at our latency right now. So in the demo file is a script you're welcome to use. It's a fairly simple script that basically pings the server 10 times and then returns what the minimum latency was. And you could store this information in a global, and you could use it to make smart decisions about what to reveal in your layout or how to execute reports. So right now, we've currently got a 2 millisecond latency between our client and server right here. Now I'm going to switch over to an administrator account so that I can use one of Apple's utilities, developer utilities. Well, how many times do you have to type your password in front of a group, right? There we go. All right, so this is actually a preference pane. If you sign up for a free developer account, you can download this set of tools from Apple. And they have a bunch of simulated networks, like a very bad network that has 10% packet loss. I probably wouldn't subject myself to that bad of a simulation, but for most of our tests now, we're going to use an intra-city profile that I created. It basically adds 25 milliseconds to the path going there and back. So we'll go ahead and flip this on, and then we'll switch back over to our end user account. And if we run our latency checker script, now we're going to see that it's 27 milliseconds. So we basically added a 25 millisecond penalty to the typical round trip to the server. All right, so let's go ahead and fire up one of the demos here. So I want a fresh start, so I'm going to quit FileMaker to get rid of any session caches that might still have been there, and we will reopen the solution. All right, try to blow that up a little bit so you can see where I'm going. And then we're going to restart our Wireshark capture here so we can get some statistics on this. And then we're going to open this region list. And I did click, I promise. Here's our beach ball. We can see the traffic flowing by here. There's a lot of requests and replies going back and forth of the server to be able to prepare this layout. And now it's loaded. So we've got 4 records and 4 columns. This is sort of an executive summary of the stock situation across the regions. And the total load time here was about 16.5 seconds, and quite a few round trips to achieve this. So what went wrong? This is sort of the legacy solution layout, and we're going to pick it apart and figure out what we could do about reapproaching this problem in a way that's not so slow. And by the way, the 25 milliseconds is a pretty small penalty. I mean, it's not even necessarily leaving the state. You might just have remote users in town that are experiencing this kind of latency and having to wait this long for a layout to load. So one of the things I ended up doing is I basically just took that layout and I just started eliminating things and then rerunning my benchmarks to see what cost the most. So what I ended up doing for you guys is I built this cost map. And so when I started out with an empty layout with just this theme and the headers and no actual fields on the layout. The download required 14 round trips when I switched to the layout. So over the WAN, that's about 1/3 of a second. And then when I added the first field to the layout, that was a stored field from the plant table, and that cost me an extra 2 round trips. So this is interesting because it means that the records, I'm pretty sure the records were not actually fetched until there was a field on the layout that required the records. FileMaker's approach to a lot of things is to load things just in time, so you're not wasting your resources on things you don't need. Then when I added the plant column, I happen to know that this is a calculation that requires reaching out to a related table and counting the unique primary keys that are there. And so that added an extra 9 trips to display that column. When I decided to add the total units column, that added an additional 103 round trips, and then adding the valuation column. Each one of these, I kind of organized them this way on purpose. Each one of them is actually triggering a reach 1 hop deeper into the relationship graph in order to aggregate the calculations. So it's pretty easy to realize here that we need to focus our time and energy on trying to make the stuff on the right-hand side go away or be handled in a much faster fashion. And yeah, so let's look at how we could do some of that. So the first optimization I'm going to look at is using found count. I didn't find this. There's actually been several good blog posts about this. If you do some searches for get found count, you'll probably run into one of them. And this approach, instead of using a calculated field that was right on the layout, I'm actually going to read from a related field on the plant table. And that related field is a very simple calculation that's just get found count. The other important thing is that you check the box that says do not store results. And this allows FileMaker to do a just-in-time evaluation of this calculation that basically returns the number of records that were on the far side of the relationship. So when we actually look at the network behavior of that, don't close the solution because then you lose your spot. That was this one. So switching out from doing the count function, which is actually an aggregate function that's retrieving the keys of the related records and then counting them, using this get found count inside of a related field actually dropped us from 9 round trips down to 5. So that's a small gain, but depending on your situation and how many records you're dealing with or how far away the relationship is, this might be something that's really helpful for you. So that one didn't help too much. Let's jump out and look at another option. I'm calling this one progressive disclosure. And this is basically going back to that stakeholder and asking them, how often do you really need the stock totals? How often do you really need the valuation? Maybe we could hide that. And so we can put it behind something like a popover or hide calculation. And then on demand, we've got like a 3 or 4 second delay to reveal the expensive calculation. So the layout itself can load fast, and then we only pay the penalty for this expensive calculation when it's needed. So depending on how often they're viewing that, this might be an acceptable way to really quickly improve the load time of the core part of the layout. So if we look at the net results of that, so adding the popover button actually didn't add any cost to the layout. It didn't make the layout any more expensive to load. And the cost each time I reveal these 2 fields in the popover is 143 round trips, about 4 seconds. And it's per disclosure. So, and the interesting thing here is if you actually just click through all 4 and then count the packets and then compare that to where we started, it's exactly the same. So if people are going to be revealing the data all the time, you might as well just show it to them. But if they're not going to need it all the time, this might be something you could use as a quick and easy approach to make the base layout load faster. All right, so now we're going to get a little more sophisticated. We're going to use virtual list. So we're going to start with the cold start, make sure we don't have anything cached in our session, and fire back up. There's a bunch of different great articles about virtual list if you haven't done it before. There's more than one way to do it. I think they're all probably quite good. So this one here, we're going to run a script. It's going to fire off a PSOS script, which basically computes all the data we need for our grid of 4 by 4, and then send it back to us, and we're going to render it on some temporary records. And that loaded up pretty quick. It's just a couple seconds. And essentially, we achieved the same result, but we're kind of decoupled from the actual data now. We just sort of have a one-time execution of a report that came back. And the way this one's working, if you pull apart the demo, you'll see that basically we just have a repeating global, one for each row, and then we've used JSON to have the field information broken out. So this is what came back from our PSOS script that we're then sticking on the layout. And I'm using calculated button labels to mine the values out of that JSON. All right, so how did that look as far as on the wire? So when we look at the before and after of this optimization, we went from about 600 round trips down to 51. So that seems really good. The amount of time for this layout to load with our 25 millisecond penalty dropped from 16 seconds down to 2 seconds. So that's probably going to be acceptable for a lot of reports. Most people, especially if they're remote, if they can get their report in 2 seconds, probably not going to have too many complaints. There's a little bit of trade-off here. Essentially, anytime you use PSOS, you are moving some of the work that you would have done on the client to the server. And so if we monitor the server while this is happening, we'll see about a third of a second, we'll have a CPU burst where the PSOS thread starts, it has to open the files, has to query the records, tabulate everything, and return it back. So as long as you don't have too many users running PSOS scripts, or you have enough cores to handle all of them, then that's probably not a concern. This is a fairly small report, but it would be something to keep in mind if you're throwing a lot bigger project at the server. And then our last round here, we're going to do, we'll do a cold start again to make it a fair comparison. All right, this one is using cached calculations that we've pushed into those region stat records. So just to prove that we still have some network latency here, we've got 27 milliseconds right now. And I'm going to just go ahead and switch over to that layout. And we're loaded. So this one, instead of, we're still on the region table, so our name label is coming from the region table, but we're going one hop away to our region stats record. So there's basically 2 records have to be loaded for each of these rows. This is beneficial because if someone else is refreshing the totals, you don't necessarily want that on the region record itself because no one else can be modifying the region record and then someone else pushing new statistics on the region. So by partitioning these into 2 records, we can sort of reserve the region stats record for something that the server updates, and then the region record for something that users update, and they aren't going to run into each other. Same thing for these other 2 fields. And then I've got a little button here. If I don't trust this data and I want to refresh it, I can just click that, and the server is going to go run a PSOS script to push new totals in, or if I want to refresh all of them. So the real challenge anytime you cache like this or denormalize is keeping your data current, because now you're no longer working with the live calculation. You're always at risk for showing something that's outdated. So it really depends on the use case. If this is a report that just needs to be current daily, then you could run a server schedule that updates the cache information or the statistics once a night. If it needs to be closer to real time, then you really have to go and do the effort of basically chasing down anytime one of the components of these calculations might change, and then hooking a trigger up to that or some kind of business process that controls those edits to make sure that you automatically fire your cache update. And if we look at the sort of before and after for this last one, so now we've gone from 600 trips to the server and back down to 33, and we've gone from 16 seconds down to under a second. So that's a radically better situation, but it does require some extra development work, so it's kind of up to you to decide if this is something you need to do. And again, we've deferred some of the work to the server, so if I decide to click one of these refresh buttons over here, kicking off a PSOS script, that does take about 20 round trips, but that's still relatively inexpensive. And then the interesting thing with this is that we're detaching that script. We're not waiting for the result. So a little bit later, the records are updated, and then the server has to notify us that we're looking at stale information. We get the new version of the statistics. So that's another 10 round trips as the refreshed data we're being notified about it and receiving it. All right, so let's switch gears a little bit over to a different type of demo. This one, we're going to look at a different optimization, and that has to do with portals. So this one right here, it's a pretty simple layout. We're looking at our plant detail. We've got fields for an address, things like that, how many employees work at this plant, and then we have a portal that's looking at records one step away so we can see the inventory that's in stock at that plant. And so we've got our stock field right here. It's right on the inventory table. And then we've normalized our product information to be stored on the product table. So that's actually one more trip a little bit farther away to get the name of the product. This actually loaded just fine even over the WAN, but it's an interesting situation. So let's look at something that we could do to change this a little bit. So this layout is achieving the exact same result with a slightly different approach. In this case, we're actually showing the product ID, the foreign key of the inventory record. So this is a field from the portal row itself without having to reach farther. And this is actually a Uuid, which my users aren't going to want to see. So I'm using a pop-up menu. And even though this field is not editable, I'm still using a pop-up menu. And my value lists, these are my favorite kind of value lists ever, are two key key value lists, or dictionary value list, whatever you want to call them. But basically, we're mapping between the ID and the name in this situation, and it works great because our IDs are unique and our names are unique. So what happens here is that FileMaker actually sort of builds a little, maybe someday it'll be JSON or something, but basically a dictionary of all these IDs and names as a sort of a package deal, and it can cache that value list, and then we can take advantage of that. So when we look at the network behavior of this, and I forgot to scroll. There's a couple more records here. And I don't know if you noticed, but as I was scrolling, there was a little blip over here on our Wireshark that it was loading more data. So let's look at what happened here. So before optimization, we had 41 round trips to load the layout initially. And then as we scrolled down to reveal the last two records that were out of view, there were 7 additional round trips to grab those stock values and the product names. By using the value list and the pop-up on the foreign key and not reaching out to that product table, we actually got the initial load down to 29 round trips, and then as we scrolled, there was only 1 additional round trip. So this is, proportionally, this is a pretty good gain. Our layout was so fast already, it didn't really make a difference, but this type of optimization might be beneficial if you have a lot of normalized data that you're going one hop away to get a label of something. If that's unique, consider making it a pop-up with a value list instead, and you might be able to save a trip to that table as you're rendering the portal. And that works with lists too, not just, actually works anywhere. It doesn't have to be in a portal, but I use it the most in portals and lists. All right, so what about if we have a slightly different layout? We've decided that we need to see the product cost and we need to calculate the valuation of that inventory. Now we need that product record again, the one that we just saved ourselves having to go get. So optimizing this product name to use a pop-up menu doesn't gain us anything. It actually might even be a little bit slower. So if you're going to need the record from that table anyway, don't bother trying to optimize it. But if you only need the label of the record or the name of the plant or something like that, then that would be time to think about seeing if you can save yourself a few trips. The other thing I was going to mention here is that I think conditional formatting and hide calculations and the like get a bad rap. Lots of times I hear people say, oh, this layout is slow because it's loaded with conditional formatting or something like that. I think that's not true. I think conditional formatting and hide calculations are awesome, and I use them a lot. But I think you can make bad calculations, and those calculations can be expensive. So just for fun here, I added some coloring on situations that had high stock or something like that. And I have some hide conditions here on some labels that are appearing and disappearing. And the before and after, the network activity for this portal had no change because the calculations that I'm using only take advantage of data which was already being fetched for those records. I'm not requiring any new queries or any new relationships to be traversed, anything like that. So go gangbusters with your hide calculations and conditional formatting. Just so long as you make smart calculations, you should be good. All right, how are we doing here? Time is ticking away. Let's see if we can get through all this. All right, we're going to do one more cold start, and we're going to jump over to a new type of layout that's a big list. All right, so we've still got our latency turned on. We're going to jump over to this inventory list tab, and let's open this big inventory list. Maybe we'll restart our capture before we do. All right, we're waiting a little bit, not too long, it wasn't too bad. Where this one really starts to hurt is when I want to scroll. So I'm going to kind of swiping, come on. Swiping. Maybe I'll, oh, I jumped to the bottom. I didn't even see what happened in the middle. I'm going to try to scroll up. This is really starting to hurt. We can see the network going crazy over here. So maybe you just try to talk your users out of having interfaces like this. But sometimes, you know, they're like, I'm paying you, you're going to do what I say, or whatever. So what can we do about this? Why is this so painful? Let's see here. So we're going to try again with an optimized layout. We'll get a fresh start here. And we'll go to an optimized version of that list. All right, we're open, and we're going to just fly through here, and it's like wicked fast, right? So what's so different about this? Well, I basically took all the things that we kind of learned about in the last few optimizations and put them all together. So every one of these fields was expensive for some reason, and we used an optimization. So some of them are using the value list ID conversion with a pop-up menu. Some of them are denormalizing with like an auto enter because my region names almost never change. So I'm going to go ahead and cache that on the plant. And then my stock and valuation, I'm going to use a server-side schedule to refresh those with my refresh buttons here. And the net difference is going to have a huge impact on how well it behaves. So let's look at the actual numbers here. So before optimization, when I first loaded the layout, I was 101 round trips to just get stuff on screen. And then as I crept my way from top to bottom, there was almost 2,000 additional trips to the server that I had to make. That's a lot of trips. And if it was somebody with even more latency, they probably would have like screamed or force quit or something terrible. So after optimization, it's only 31 round trips, and scrolling top to bottom was only 29 additional round trips. So even with a decent amount of latency, this layout could feel really good. And your users are going to be really satisfied with something like that. All right. So there's a little bit more I was hoping to get to, but we're actually going to put that in the homework tab here. So this is why you got to download the file and look at this other optimization. This is a technique I actually wrote a blog post about at the end of last year called reverse natural sort. And it's a trick for sorting without having to download the whole table. And so that if you're seeing a lot of like sort, dunk, 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 a lot of waiting with that, this would be something to look at. It might benefit you. All right, let's go back over to the slides here. All right, so if there's anything to learn or take away other than to spend time with the demo file later, is that you should really test with representative data and networks of what your end users are going to eventually be on. And I think I'm guilty of this too. It's real easy to test with just a few records and prove that your code is right. But if you can actually generate a bunch of sample data or find census data or something you can import into your solution to have something that's representative of what it's going to look like 12 months from now, then you're going to get more realistic performance assessment of how things are going to work. And then work on a LAN. Maybe use the latency tool that I did. There's a similar tool available for Windows that I think is free as well. Just remember, if you're going to degrade your network performance, it affects all your network performance. So after you're done testing, like a couple hours ago, I was like, man, the Wi-Fi here at the hotel is terrible. Oh, I'm on 3G mode still. You know, I had to turn off my conditioner. Study your round trips. Find out how long it takes to get from your client to your server. And then do things to avoid extra trips. And then just sort of in the back of your head, as you're developing, as you're throwing stuff on the layout, and it's just so easy to just build stuff so fast, at least in the back of your head, you should start having this sort of equation about what's it going to cost for this element to actually appear to the user when there's real data, and is it worth it? You know, there should be a little bit of assessment that goes on for you there. All right, so just a reminder that we will update the slides and they'll get posted, so feel free to check back in for those. And evaluations are helpful for me and for the people who organize the conference, so please fill those out. And I think we have just 5 minutes or so for some Q&A. There's a mic down here if you guys have any questions or things that you think we could do to make it even better. We'd love to hear that. So come on down.
Okay, sorry. A lot of people realize when they went from a 200 meg service to their gig service at home and then they remote into FileMaker, they realize it's just slow. They don't see 5 times the improvement.
Right.
One of the things in the Wireshark, you see that the packet sizes of those Corba packets are 66 bytes, 139 bytes, a lot of round trips. So by the time you put the TCP wrapper on top of all those packets, that's where most of the latency delay is because FileMaker sends so many tiny, tiny communication packets.
Yeah.
And so have you found any kind of optimization inside the networking in general, other than your optimizations?
Yeah, I don't know that there's a lot. I mean, we can encourage the engineers to look for ways to achieve the same results in fewer trips. I don't know that there's a lot that we can do other than sort of observe, you know, portals that reach 3 relationships away are really expensive or something like that. And I don't know that the that there's any sort of networking or hardware overhead involved in those. It's really just the geography, how long it takes the light or the electrons to get from your client side to the server, and multiplied by the number of round trips. So I don't know that there's, if there was a magic bullet, I would definitely show it. And that's why I think a lot of people use terminal server, especially if you have a legacy solution with a lot of existing calculations and code that were all written when users were on the LAN, trying to expect that same kind of performance when they are connecting with a geography barrier is pretty hard.
When it comes to portal performance, how would compare to have a condition in the layout for filtering dynamically a portal versus, if possible, you can do that condition in the relationship graph?
In the relationship? Mm-hmm. I think it depends. It's one of those things that I would generally just test to see which is better. I know that there are some specific built-in optimizations when you use filtered portals. But I've also seen really good benefits of using extra keys on the relationship to set like a date range or something so that you're not fetching everything from the relationship. So that feels pretty good too. I really like both methods. It sort of depends on the interface and what I'm trying to accomplish. I don't know that one is necessarily always better than the other. Yeah.
As far as narrow and wide tables, do you have kind of your own general rule of thumb about how many fields you feel comfortable putting in a table before you say, this is too wide, and starting to figure that you want to break things apart?
I actually think the number of fields doesn't matter other than it makes my brain hurt. The number of fields with data matters a lot. So everything that I've tested and seen basically indicates that when you go to fetch a record, you get the whole record. However many bytes are stored in stored fields of that record. And if it's 1,000 tiny fields, or if it's one field with War and Peace in it, I would expect the penalty to be similar. So I think the issue there is just more for maintainability and sanity maybe than design. I've also actually started using more unstored fields as a way of narrowing records. So usually we frown on unstored fields, unstored calculations, because they can't be indexed, you can't find on them quickly. But it does mean you're not storing the data. So if your goal is a narrower record, you might achieve that by calculating the data later instead of storing it. Sometimes you can come out ahead with unstoreds. But it's something to keep in mind. So if you have fields that are calculated that are stored, those are actually getting committed with the record, and then that minimal amount of data that's going to come is going to include that. Whereas if it's unstored, then it's only going to be calculated the first time you reveal that field on a layout or use it in a script or something. So that sort of on-demand cost might be better than the size that it is. It really depends. Yeah, I don't know if there's one right answer for that. Yep.
I had a question about the ID popover, overriding the formatting. The field you were showing was in the same record. The name you were showing in your value list was from the exact same table.
The foreign key was in the same table. Back when I was showing the product name.
The name was also in that table.
It's actually one away. It's normalized out to, so my inventory record doesn't store the name of the product. It only stores the ID of the product. Unless I botched the demo file, but I'm sure at one point it was correct.
It looked like it, okay.
All right. All right, any last question before we're time's up?
When you show times for between continents, and we deal with this now to the UK and Shanghai, at what point am I just not going to be able to, if I'm dealing with crossing a continent, so it's just at some point it's not going to have any effect, because even though I have less hops, I just still physically have to cover that distance geographically.
Are you talking about like, are the networks going to eventually get better and it won't matter? Or, I'm not sure if I understand.
We are debating how much this approach helps versus going to actually us to sync. So basically
Right.
storing the data
Okay.
locally and then syncing it back.
Well, there's a certain, I mean, we can only reduce the number of hops so much, and then the rest we would sort of depend on the Draco engine to maybe come up with more optimizations there. And going from one continent to another, I think, is always going to be really challenging.
Yeah.
Even if they make improvements, even if we're smart, most of my users' expectations of how fast they want it to respond probably wouldn't be satisfied there, I would think.
Thank you.
Yeah. All right, thanks everybody for coming. We're going to move out.